Hello everyone. Today we are going to solve this problem of the day from GFG. Given a linked list of zeros, ones and twos, we have to sort it. So there are n nodes and each of them contain the values 0, ones and twos only, and the task is to segregate them. So basically what we can do is count the number of ones, twos and zeros, and once we have all these counters, we can just iterate through the nodes and keep on changing the values of these nodes to 0 first, then 1 and 2, according to the number of according to the count that we had calculated earlier. So instead of using doing that, what I'm going to do here is keep track of 0 head and 1 head, 2 head, and similarly their tails as well, so that I can sort them in memory without altering the actual node. So basically what I mean to say that if this node has the value 0, so this node in memory should come in front. And if we use the counter approach, we will just make change into the uh, node storing the value 1. So that is not the correct way. If for this question it may get passed, but that is not the correct way in interviews and all. So what I'm trying to say here is we'll start with declaring uh, the heads and tails for all of them. So just for the convention, say z is 0 and head, okay, z 0 head, 0 head, then we will have a 0 tail, then we will have 1 head, then we will have 1 tail, then we will have th, finally tt. Now we will need a current node to iterate through the linked list, so it will be equal to head itself. Now let us start iterating through the list while current is not equal to null. So our first case will be if current data data is equal to 0. So what happens if the current node is 0? So we'll just uh, what we are doing here is we are making three separate lists of zeros, ones and twos, and finally we will just link them. So if the data is 0, we will have to connect this current node to the list of zeros. So how do I check that I already have a list of zeros or not? So if 0 head is not equal to null, so basically if the 0 head is null here, yes, if if 0 head is equal to null, then this will get true. That means that there is no list of zeros, and we will just assign the current node as the 0 head. Fine. And otherwise there is already a node, a list maintaining the zeros, so then we will just make the 0 tails next point to the current node, and finally the 0 tail becomes the current node. Now in a very similar fashion we will do this for 1 and 2 as well. So here I'm going to just write oh, ot and ot, and finally for 2 it will be th, th, tt and tt, and finally we just need to keep on updating our current loop as well. Now what we have got is three lists starting from zh, oh and th, storing the list of zeros, ones and twos, and we need to connect them. So if there is a list of zeros, that means there will be a 0 tail. So if there is a 0 tail, that means there is a 0 list, and we need to point its next pointer to oh head. So we will just point it next to oh. Similarly, if there is a list of ones, then there will be its tail will be existing, and we will need to point its next to the head of twos. So even if two's head is null, it doesn't matter because we can point a tail to null. Now what happens if there is, so basically we have just marked the nodes next value only. So if we want to store, like if there is a node after 2 as well, and whose next we have not changed, then there will be a cyclic node. So we need to also check if there is a 2 tail, basically then we will just point it to the to null, so that we tell that this is the end of the list and it does not point back to any other 0 or 1. Right. Now one thing we can also check as an edge case is what happens if there is no 1 and there are only zeros and twos. So I'm just pointing this jet's tail to 1's head, and if it is null, then there will be no link to the 2's head. So basically I'll just need to check if there is O head, then I have to connect it to O head, otherwise I will connect it to TH head. Now what we will return is, we will again need to check what is present and what not. So we will make use of ternary operators again. So if ZH is present, then we will just pass ZH. Otherwise, we will check if OH is present, then we will pass OH, and if not, then we will pass 2 head. So basically, first we will try to send back the zeros list. If it is not present, then ones list, and finally the twos list. We'll just compile it. We got a runtime error. So what we can do here is make everything null. By default, then again try it. Yes, so it gets compiled. Let's submit it. And it got accepted. So that was all for today. See you tomorrow.